Okay, Megan, you're still here, but you're not here. Here we go. Example 6. What's this first one say? Oh, first of all, here's our graph. This is not an actual function. This is just random points. There are 4 points. Yeah? 4 random points, okay? That's why they call it f of x instead of giving it like a function like x squared or whatever, okay? What is this negative doing? How does that negative move him? And how does this negative move him? Which one is which? Over the, if the negative's out front, it flips him over the x-axis. Negative inside flips him over the y-axis. Okay, so first of all, part A, I'm gonna do that in red. I'll do this one in blue. Over the y-axis. Okay, so over the x-axis first. All right, I'm gonna take each one of these points and I'm gonna flip him over the x-axis. X-axis is right here. So where does this dot go? If I'm flipping him over that x-axis, he's now right here. Yeah? Where does this dot go? 2 below. What about this one? 2 below again. What about this one? It stays on there. So now he looks like this. That's flipped over the x-axis. Happy with that? Does that make sense? Over the x-axis? Okay, now we're going over the y-axis for part B, okay? Where does this guy move? He stays. He's on the y-axis. What about this guy? Over 3 on this side, right? This guy is 4 on this side. This guy goes to 5 over, but he's on the x-axis, right? So he looks like this. Over x over y. Does that make sense? Yeah, not too bad. Okay, now the reason why they call that f of x is because he's just like a random like function. He is actually a piecewise function is what he's called. Have we talked about piecewise functions in here? He's like 3 different pieces. He's this linear function, this linear function, this linear function. We'll get to that. Okay, good? Happy with that? That is over x over y. Okay, last thing. This is what I was already quizzing you on. When they give you like a bunch of things to happen all at the same time. What is this guy's parent function? Start with that. Y equals, if I strip everything else away, x squared will be left, right? Okay, so x squared, we don't deal with those. Okay, now we have to figure out what all the other things are doing, right? How many other things, oh, by the way, let's graph x squared. You know what x squared looks like? He looks like a parabola, so he starts at 0, 0. Then, if we go over 1, 1 squared is 1. 2 goes up to 4, right? 3 would go up to 9, which is like there-ish, right? Okay, and he's the same on the other side, right? He's a parabola that looks like this-ish. Something of that nature. Oof. Whatever. That's our parent. That's what we're starting with. We're starting with that guy. Okay, now I have to figure out what all other things are happening to him. So, as far as transformations go. Oh, heavens. Okay. Okay. How many are there?
4.
There are 4. There are negative, 1/2, minus 2, plus 3. Those 4 things are happening. All right, so I'm going to put 1, 2, 3, 4. Oofda. All right, which one of those 4 things is happening first? Yeah, if I were to plug a number in for x, I would subtract the 2 first. Okay, how does minus 2 move him? To the right 2. Okay, we'll just list all of these and then we'll do them. Okay, then are you going to apply the negative, the 1/2, or the 3 next? 1/2 or negative, doesn't matter, right? So let's just do 1/2. How does the 1/2 change him? Vertical compression by 1/2, right? Like it's making them shorter, okay? Oh, heavens. All right. Then are you going to do the negative or the 3? Negative. And that moves him? It flips him over the x-axis. Over the x-axis. And then the plus 3 moves him up 3. Oh, we got lots of stuff going on. Okay. All right.
Shouldn't it be up 3 and then...
No. So, Remington, hold on just a second. Okay, don't listen to this. Don't listen to this. One thing that you could do is if you take it and you flip it and then move up 3, right? You could have moved down 3 and then flipped it, right? Okay, now here's the deal. Let me show you why. What I could have done with this guy, that is the same thing as that, true? And if that's the order, right, because if I just distribute my negative for those pieces, right? If that's the case, then I would do this first, this second, this third, and the negative last. Okay? So you could go down and then flip it, right? But according to the way that it's written here, you're going to flip it and then go up. But I'm just showing you that like going down and then flipping would be the same thing as flipping first and then going up. So, yeah. There are different ways of writing it, and that's totally fine. But the way that it's written here will go in that order, okay? All right, don't write this down until the last step, okay? I'm going to write it up here, and I'll go through all our steps, and then I'm going to have you draw the last guy because it's kind of a mess, okay? So I'm going to take this guy, and I'm going to go to the right 2. So everything's to the right 2. Now he looks like this-ish, right? That's right 2. That's my first step. Done. Now, vertical compression by 1/2. This is where it gets a little ugly, okay? If I take vertically, I'm going to take him and like squish him this direction, right? I'm going to squish him toward the x-axis, right? This dot is not going to change. He's on the x-axis. He's not going to change. This guy is at 1, but if I vertically compress him by 1/2, now he's half the distance to the goal, right? So he's going to be shifted down here. Same thing with this guy, right? This guy is 4 above, so now he's going to be 2 above. Right? And same thing over here, 2 above. So now, after I vertically compress him, he looks like this. He's squishier. Does that make sense? That's after step 2. Ooh. Now, the last 2 things, we have to flip him over the x-axis. So I'm going to do that. I'm going to flip him down. Down and down. So now he looks like this after I flip him down. Okay? And then I'm going to move him up 3. Oh, Lordy. I'm running out of colors. We'll go back to black. Up 3 units. So there. This is my final guy. Ooh. Okay. You see after we did all of those things? He's like a little bit wider and a little bit shorter, right? But like he's moved around and done all those things. Okay, got it? All right, graph him. So this first dot is at 2, 3. That's where your vertex is. And then like he's a halvesy and then like 2 over and 2 down from there. Okay, so graph him. 2, 3. This guy is right there. And then this guy's right here and make him symmetric. This is 4, 1. Okay, this guy is 3, 2.5. Those are my 3 dots and then the same on the other side. That's the black guy. The black guy is the one you're graphing. Okay, what a mess. Okay, but still more pleasant than having to plot points, X and Y. Ugh, that would be terrible. Okay, good. We got one more of those. Okay, ready? Last one. Ugh, this one's not as bad, I don't think, right? First of all, parent function is what? The square root of x. Okay, if I strip everything away, y equals the square root of x. Are you guys okay with telling like that's the parent function? You can kind of decipher that. Okay, square root of x. Let's map out what he looks like. What does the square root of x look like? If you need to cheat, go back to the first page of these notes. We have all the ones. Yeah, so he starts at 0. And then he goes like this direction. But let's get some actual points. So if I go over to 1, the square root of x, square root of 1 is 1, right? The next nice number to take the square root of is 4, and 4 will be at 2, right? The next nice number is 9, and 9 will be at 3. So something like this, and this is what he looks like. He's like the top half of a parabola on its side. That's what the square root of x looks like. This is our parent. Okay? Good? All right. Next. This one's not so bad. All right. We have to figure out the transformations. What's happening? How many things are happening to him?
2.
Nope.
Oh, I didn't even see
Three things are happening, right? 1, 2, 3. They are this guy, this guy, this guy. Okay. Now we have to figure out what order they're going to go in. So if I plug a number in for x, which thing would you apply first? Then this negative right here, right? Okay, and that negative tells you that you are going over what? The y-axis, over the y-axis, okay? All right, the negative that's inside the square root is over the y. Okay, now, am I going to apply the negative or the 2?
2.
I'm going to add the 2, and adding the 2 moves him to the left 2, because he's underneath, right? Okay, so we apply the negative, we add the 2, and then we apply the last negative. The last negative is going to flip him over the x. Last one flips him over the x. Okay. All right. Okay, keep in mind that we have starting points. We have this dot, this dot, this dot, this dot, right, to help us to figure out where we're going to go. All right. If I'm flipping it over the y-axis, can you visualize what's going to happen over the y-axis? Flips him that direction. Oh, y-axis is here, so I'm going to take this guy and I'm going to flip him over here. Okay, so this guy's going to stay. This guy goes here. This guy goes here. And then, like, my 9 over here is whatever. This is what he looks like to begin with. Got it? That's after step 1. Okay? After step 2, I'm moving him to the left 2. Can you visualize moving him to the left 2? This guy's going here. This guy's going here. This guy's going here, etc. That's left 2. And then, last step, I flip him over the x-axis. Can you visualize flipping him over the x-axis? He's going to get flipped down, right? This guy's going to stay. This guy gets flipped down. This guy gets flipped down. And he looks like this. This is my final guy. That black one. Got it? Yeah. Okay? Happy with that? Sometimes they're ugly. Okay. Good? Questions? All right. You guys have, I don't know what our homework assignment is. A lot of homework assignments. Are they all graphing? Or are they just like tell what the transformation is? Yes, don't graph. Perfect. Okay, so, yeah, the homework assignment says this. Let me write that down. What are we on? Don't graph. Yeah, okay. 9 through 14 must be matching, right? Page 150. 9 through 14 is all. That must be a matching thing. And then, oh gosh, we got lots. 16 and 18 and 20 and 24 and 28 and 30 and 36 and, oh my lordy, 40 and 48 and 50 and 72 and 76. And that's it. And it says just list, don't graph. Do you know what that means? Just list, don't graph. So when we were filling these out, right, and we did the parent and the transformation, and sometimes the transformation would have like a 1, a 2, and a 3, okay? That's what you need to list. So just this part, don't graph the thing. Got it? Okay? All right. And those will make it go way faster. Good, good? Okay. All right. Goodbye, Megan.